Hey guys, Fiorine here. We're gonna go ahead and look at Unit 1, Note 6. We're gonna be solving linear and absolute value equations. So, still nothing that is brand new to you guys. You've seen this before, but we need to know these basics and remember these basics when we get into looking at the graphs of these things and how the functions work and being able to really dig into them. So, let's look at linear equations. There's only two examples here that I wanna look into because again, you've been doing this for so long that I don't know how much you actually really need of it, but we wanna make sure that you fully are confident in with it. So number one here, I got this big long thing. Remember, when you're looking at this and you're solving equations, you have a right side and a left side, and that comes from that equal sign. I always wanna deal with distributing through those parentheses first. So I'm gonna go ahead and I'm gonna distribute this side, but I also see parentheses over here, so I'm gonna do both of them in the same step. So this first one's gonna give me 2x minus 6. Notice that minus 17 is not in parentheses, so that's gonna stay the same. That 13 is not in parentheses. Now you are technically distributing a negative 3. So I'm gonna have minus 3x minus 6. So now we wanna go ahead and I'm gonna combine like terms on each side to make life a little easier for myself because I see constants on both sides that I can put together. So I have negative 6 minus 17 that I'm gonna go ahead and put together, and I'm gonna get negative 23. So I'm gonna have 2x minus 23 on this side. And then I have 13 minus 6 on that side that I'm gonna go ahead and put together. So I have negative 3x plus 7. So now we're just gonna get our x's to one side and our numbers to the other. So I'm gonna go ahead and move this this negative 3x to the other side by adding it. We have 5x minus 23. These are going to cancel out, so I'm going to be left with 7. So now to get rid of that minus 23, I'm going to go ahead and add 23 to both sides. So I get 5x is equal to 30. Now to get rid of timesing by 5, we divide by 5. So x is going to equal 6. Let's go ahead and look at this problem. We hate fractions, right? Hate fractions. So let's go ahead and get rid of this fraction right away. I have to get rid of the dividing by 4 and the dividing by 3. So what I'm going to do is I'm going to multiply this whole thing by 12. Okay? And what that's going to do is that's going to allow me to simplify each thing. So it's really going to have 12 times x plus 2 over 4 minus 12 times x minus 1 over 3 equal to 2 times 12. So I just basically multiplied each thing by 12, which I can do as long as I do it to everything. So when I do that, I'm going to simplify this fraction then. 12 divided by 4 is going to give me 3, so I'm going to have 3x plus 2 now. 12 divided by 3 is going to give me 4 times x minus 1. And then 2 times 12 is going to give me 24. So now I have my right side and my left side, and I can go ahead and solve like I was doing before. So we're going to distribute. So I'm going to get 3x plus 6 minus 4x. Negative times a negative is a positive, equal to 24. And I'm going to combine like terms. So I have a 3x minus 4x on one side. Because they're on the same side, I do not have to change the signs. I'm just combining them together. So I'm going to get negative 1x. 6 plus 4 is going to give me plus 10 equals to 24. So now we're just solving. I'm going to subtract 10 from both sides. So I'm going to get negative 1x equals 14. And then I don't want to know what negative 1x is. I want to know what x is. So I'm going to divide by negative 1. So I'm going to get x equals 14. Okay, let's go ahead and look at solving absolute value equations now. So biggest thing you're going to do is you want to isolate the variable first. The absolute value bars first. So we're going to isolate the absolute value. Once you have the absolute value bars alone on that one side, then you can go ahead and you can separate into two equations. You're going to set one equal to the positive number and one equal to the negative number. Then you're just going to solve like normal. Okay? So when I'm looking at this, the example that I'm showing here, this absolute value of 2x plus 6 minus 3 equals 13 right here, I have to get rid of this minus 3 because that's what's on the outside. So what I normally do, and this may help you or it may not help you, is I highlight the absolute value bars. That's what I have to get alone first So I have to get rid of whatever's not highlighted before I can split into two separate equations, one equal to the positive and one equal to the negative. So let's look at example number 1 down here. When I look at this, I'm going to highlight the absolute value bars, okay? So anything that's highlighted, I want to keep. I have to get rid of everything that's not. So we always get rid of whatever is being added or subtracted first. Well, that 4 is being added. It's a positive 4, so to get rid of it, we're going to minus 4. So I'm going to have 3 times the absolute value of x plus 5 equal to 16 minus 4, 12. So now if I'm looking back up at what's not highlighted, that 3 is not highlighted. So I have to get rid of timesing by 3. So to undo timesing by 3, we're going to divide both sides by 3. So now I have the absolute value of x plus 5 equal to 4. From this point, since the absolute value, whatever was highlighted is alone, this is where you're going to split into your two equations. The thing that's inside the absolute value bars stays the same, but I change what I'm equal to be 1 positive and 1 negative. Now I'm just solving like I normally do. So I'm going to subtract 5. So x in this situation can be -1, subtract 5, or it can be -9. Both of those work to solve this equation. Let's go ahead and look at number 2 here. If I highlight the absolute value bars, there's nothing on the outside of those that I have to get alone, so I can split into 2 right away. So I'm going to have 2x over 3 plus 6 equal to 2, and 2x over 3 plus 6 equal to -2. So you're going to say, well, Furion, why did you put the x on the top? I always put the x on the top. That's just my go-to thing. The x, the variable, whatever it is, I always put on the top of a fraction. So what you're going to do then is subtract 6. We're going to just solve this like we normally know how. And we're left with 2x over 3 equals to -4, and 2x over 3 -8. So you might be asking me, like, why didn't I solve or get rid of the fraction like I did up here on this problem, okay, when we were doing the linears? Well, this had 2 fractions in it, so I really wanted to get rid of them. This one only has 1. So I kind of just look at it as solving, okay, just solving the equation. So what I would do right now to get rid of dividing by 3, I would times both sides by 3. And what that does is that just cancels out the fraction. So I'm left with 2x equals -12. I can do the same thing over here. So I'm left with 2x -24. So now we can divide everything by 2. So x is going to equal -6, or x could equal -12. All right, let's look at these last 2 examples here. Number 3, okay, so I'm going to go ahead and I'm going to highlight the absolute value. Whoop, that's not what I wanted to do. I wanted to highlight the absolute value. Okay, we're going to get rid of the things that are not highlighted. So that plus 3 is not highlighted, so we're going to subtract 3. Okay, there's my right side, left side. That's going to cancel out, so I'm left with the absolute value of x plus 5 equals to -2. Now, this is actually a special case. There is nothing that you can plug into this that when you take the absolute value of it is going to give you a negative number. Because remember, the absolute value of something is the distance away from 0. You can't have a negative distance, so you can't have an absolute value of negative. So if this ever happens where you're at the point of you would split up, but this number is already negative, then you would go ahead and you would write no solutions, and you are done. So number 4, let's look at this. Okay, this is throwing everything at you. So let's go ahead and highlight the absolute value. So here's the thing that we're trying to get alone first. Okay, so normally I would get rid of that, whatever is being added or subtracted. But that thing that's being added or subtracted, that -5 at the end, is being divided by 3 right now. So since we can't do that, we can't really do 5 divided by 3, let's go ahead and get rid of the dividing by 3 first. So to undo dividing by 3, we're going to times both sides by 3. So that's going to leave me 4 times the absolute value of 8x minus 16 minus 5 is going to equal to 27. So now I can go ahead and I can get rid of that, whatever's being added or subtracted, that's not highlighted. So I'm gonna get rid of that minus 5 by adding 5. So I'm gonna look at 32. So now I'm gonna get rid of that timesing by 4. So to get rid of timesing by 4, we're gonna go ahead and we're gonna divide everything by 4. Okay, so I'm gonna have the absolute value of 8x minus 16 equals 8. At this point, since the absolute value is now alone, we can split up into two equations, one equal to the positive of that number and one equal to the negative of that number. And we can solve both sides. So I'm gonna add 16. Excuse me. I'm gonna have 8x equals 24. And then divide by 8. So I can get x equal 3. If I do the same thing here, I'm going to get 8x equal to 8. Divide by 8, x could equal 1. Both of those answers would work inside that equation. When you plug it in for the x value, you should get all of that equal to that 9 then. All right, so that's all I got for you today. If you have questions, reach out to me. Let me help you. Otherwise, the assignment is uploaded. Go ahead and finish that on Schoology. Submit it in. And I'm hoping to see you guys tomorrow.